Hello class, welcome back. Today is lecture 11 and we're going to do more on factoring, slightly more complicated ones, and then some shortcuts. So last time you may have noticed that this box method, we only used it on a certain kind of polynomial. You may not have noticed. So we used the box method on things like, so first of all, they got to be second degree polynomials, aka only x squared at the most, no higher powers of x. And we did it for things like this, but you may have noticed that we kept using just x squared. So there's a secret one here that you don't write. But we never put other numbers. We didn't put any other numbers. And that's just because the technique, it still works for other numbers, but it's sort of a little bit different. So we're going to treat it separately. Okay, so that's what we're going to start with today. So we're going to stick other numbers there and see how the technique works. So it's going to be a little bit different, but hopefully not too bad. Okay, so let's factor this. 2x squared minus x minus 10. So it is still degree 2. We got to have degree 2 for this method to work, but now it's not just x squared, it's 2x squared. Okay, so here's how the box method works for things like this. It's a little bit trickier. So on the top, we still put this, whatever number is here in front of the x, we still put there. So it's a -1. Remember, we don't write the 1, but it is there. And on the bottom, we used to write this thing. So normally we would write -10, but it actually changes because of this 2. So we don't write the -10. Instead, we put them together. We multiply them together to give us -20, and that's what we put down there. So remember what this box is representing. It's telling us that we need to find two numbers that multiply to be whatever's on the bottom. So they got to multiply to be -20 and add up to -1. So which numbers are those? Well, it's a good idea to always start with the multiplication first. Sort of narrows it down more. And so what numbers multiply to be -20? Well, how about 5 times 4, but I need one of them to be negative. How about I make the -5, the negative be on the 5. So that will multiply to be -20. And these two numbers will add up to -1. So of course you could have tried other things first and got it wrong, but eventually you'll get to this point where you pick these two numbers and these are the ones we want. So we stick -5 and 4. It's really unnecessary to even put them there. We can just continue, but maybe it helps you visualize things. So we'll put them there. Okay, so now how we answer the question is also a little bit different. So this multiplication step was new, but there's another new step as well to answer the question. So before, you might have said, that means that the answer is it factors into x minus 5, x plus 4, because you would just take these two numbers and add them to x. But unfortunately, that's not how it works here. Not this time, it's not going to work. So instead, we got to do something a little bit different. We use this box still, but we use it to do something differently. Okay, so here's how we do it. So instead, so I'm going to rewrite the polynomial that we started with just for reference. And then what we do is, well, this -4 and 5, the whole point of these two things was that they add up to -1. So what we're going to do is we're going to replace this -1x with -5x's plus 4x's. So a very common trick in algebra is to rewrite something in a helpful way, even though they're the same. So -x does equal, it's the exact same thing as taking -5x plus 4x, but for some reason, this other form will now help us more, which is what we'll see. So everything else stays the same for now. I'm just replacing negative x with negative 5x plus 4x. So these are the same thing. That's why I can replace them with each other. Everything else will stay the same. Okay, and then to continue the next step, we're going to go back to factoring by grouping, which we only did one example of. So we don't have much practice with it, but luckily it's not so bad. It's going to come in handy here. So factor by grouping. So what that means is we're going to think of the two first terms as sort of being their own thing, and the second two terms as being their own thing, and we're going to factor them individually, meaning what goes into both 2x squared and negative 5x? Well, the only thing that goes into both of those is x. So I'm going to take out an x, and what's left is 2x and a minus 5. Okay, and then over here, what goes into 4x and negative 10? Well, the most I could factor out is a 2. So I'm going to take out a 2. And sort of magically, this will always, if we factor by grouping wisely after doing all this, this will always create a situation where these two guys are the exact same thing. So now I have this sort of strange situation where I have a 2x minus 5 in each term. So I can factor out that 2x minus 5. And so what's left from the x times 2x minus 5? Just the x. And what's left from the 2 times 2x minus 5? Just the 2. So now we're done because we've factored it into two things multiplied together, which is what we wanted to do. Okay, so this is how the technique works when it's not just a 1 in the front. So let's just do some more examples for some extra practice. All right, 2x squared plus 13x minus 7. Same idea. This little box is going to help us. So I need them to add up to 13 because of the 13 on the x there. And I need them to multiply to be negative 14 because I'm taking these two guys and I'm multiplying. 2 times negative 7 is negative 14. So now I need to find two numbers that multiply to be negative 14 and add up to 13. So you can try various things. So what about this one? 14 times negative 1, that will get you the negative 14. And 14 plus negative 1 will get you 13. So this is what we want, 14 and negative 1. So now I use my box to do that interesting step again. So let's do it here. So 2x squared plus 13x minus 7 equals, so this step again, I'm just replacing my middle 13x term with 14x plus negative 1x, which you can just write as negative x, or you could just say 14 minus x minus x, either way. In any case, that is being replaced. And then we are going to factor by grouping. So I'm going to see what can I take out of here. So out of the first two terms, I can take out a 2 and an x, because 2 goes into 2x squared and 14x, and so does x. And what's left? Well, from the 2x squared, there's just an x. From the 14x, I took out the x, and I took out a 2, so just have a 7 left. And I divide out the 2. Then over here, I really need to take out a negative 1. That way, I'll be left with an x, because the negative has been divided out, and plus 7, because then the negative has been divided out. And so now I'm in a situation where, once again, I have these two things being exactly the same, so I can factor it out. And what's left in the first one is 2x, and what's left in the second one is a negative 1. Okay, so that's the end of that one, factored out into that. Let's see, one more I think we'll do, yeah. Okay, factor this, negative 6x squared minus 14x minus 4. Same exact method. So negative 14x is the middle term. So this has got to be there. And then I got to multiply negative 6 times negative 4 to get negative 24, and that will be down here. Okay, so I need two numbers. Sorry, negative 6 times negative 4 is positive 24. Those will cancel. Okay, so we need two numbers that do what? They multiply to be 24, but they add up to negative 14. So how do I multiply to get 24? Well, I could do 2 times 12, but those don't add up to negative 14. They add up to positive 14. Aha, but I can just make them both be negative, and that will still multiply to be 24, but now they will add up to negative 14, which is what I want. So negative 2, negative 12 go there. And now I can continue. Negative 6x squared minus 14x minus 4 will equal. So I'm just going to replace this middle term again with negative 2x and a 12x being added together. And then everything should work out nice. Doing the same things as usual. Okay, so what goes into negative 6x squared and negative 2x? How about a negative 2x? Because negative 2 does go into negative 6 and leaves me with 3. X goes into x squared, leaves me with an x. And negative 2x goes into negative 2x one time. So that leaves me with a 1. And what goes into negative 12x and negative 4? How about a negative 4? That divides into negative 12 3 times and into negative 4 itself one time. And once again, these match, so we've factored out things in a wise way. And we can now take out that 3x plus 1. And what's left from the first is just the negative 2x. And what's left from the negative 4 is, or sorry, from negative 4, 3x plus 1 is just the negative 4. So we could be done here, but I just want to note one thing. In fact, you could take out a negative 2 from here. And you don't have to do this, but it's good to see different things you could do. So what happens if I take out a negative 2 from that? Then what's left is an x plus 2. So people would often write this as, then they like to take the number that's by itself and move it to the front. Because I'm multiplying three things together, I'm multiplying this times this times this. If you multiply three things together, you can rearrange the order. So I'm going to, just for aesthetic purposes, people would like to do it like this. And that's even more factored out than if I just left it like that. And then one thing that you can see, so remember the whole point of equal signs is that we're just changing the form of something, but it's the same thing that we started with. So this is really the same as what we started with. We've just written it differently. And I can see that this negative 2, I could have actually taken that out a long, long time ago, because a negative 2 goes into all three of these. So I could have originally taken out that negative 2. And I would get this. And then I could just leave that negative 2 in the front while I go off and factor this guy on the side. And if I did that using my box method, I would end up exactly with these two things here. So either way, you would get the same thing, which is good. So you can try that if you like, factor in just this piece, the box method, and seeing that you'll get the same thing. Okay. So that's enough of those examples. They're all very similar. So make sure you practice on the problems. So next I want to just go over some shortcuts. So shortcuts are always nice, except they sometimes make you forget where things come from. So that's the trade-off. So here are some interesting shortcuts. So if you have a difference of squares, is what this is called, meaning you have something squared minus something squared. So something like this, x squared minus 9. And you do the whole method, you'll always end up, when you factor it, with x minus the square root of the number. So that would be 3. And x plus the square root of the number. So you could do this using the method if you want, but it'll always work like this. So in general, what people do is they write something like this. X squared minus a squared equals x minus a, x plus a. So here, we're just using a equals 3, because x squared minus 9 is really x squared minus 3 squared, because 9 is 3 squared. So that's why it's called a difference of squares, because you're doing x squared minus a number squared. So for example, x squared minus 16 will be x minus 4, x plus 4. And you can show it by actually doing the whole method if you want, just to see that it always works. Another way to check that this always works is to actually multiply this out. So multiply this thing out like you know how to do, and it will turn into the left side every time. It also works for slightly more complicated things. So for example, it doesn't have to just be x squared. It could be something like 4x squared minus 49. So now it's still a difference of squares, but it's not just x squared here. It's still something squared though. So what is it? Well, 4 is 2 squared. So what I have to do is write this as 2x and then square that, minus 7 squared. And then I can still use the formula, but instead of just x minus a, x plus a, I replace x with this thing. So it's 2x minus a, where a is 7, and 2x plus a, where a is 7. So it still works like that. And I could do like one more, I don't know, about 9x squared minus 81. Well, this is 3x squared minus 9 squared. So it's 3x minus 9, 3x plus 9. Okay, so that's the difference of squares. One thing I want to warn you about is x squared plus a squared is not factorable. You cannot factor this any further. So it's got to be a minus. Very important that it's a minus. This plus will not work. You can never factor this. Okay, the next shortcut it very often appears when you have something like this. We haven't seen much like this, but you will eventually see this a lot. It comes from this, x plus 2 squared. Or let me use a different number, 2 is 3. So the next shortcut comes from doing this guy. So the idea here is, first let me write what's bad. This is what bad people do. Bad. They think that it should just be x squared plus 3 squared, because what they do is they take the square and they just put it to each thing. So then that would just say x squared plus 9. But that's not what you get. In fact, I just told you that that's not what you should get, because I said something like this is not factorable. And this is saying x squared plus 3 squared is factorable into this, which is really x plus 3 squared really means x plus 3 times x plus 3. So that's why this is all bad. This is not how it works. So instead, you have to actually multiply it out by knowing what it means. it means x plus 3 times x plus 3. And if you multiply this all out, you'll get x squared plus 3x plus another 3x plus a 9. So instead you get x squared plus 6x plus 9. And the shortcut is really that it's x squared plus 2 times 3x plus 3 squared. So that's the way it will always work if I change these numbers around. So let me write that. So in general, the idea is x plus a squared is going to be x squared plus 2 times ax plus a squared. So for example, if I do x plus 4 squared, it'll be x squared plus 2 times 4x plus 4 squared, aka x squared plus 8x plus 16. So if you multiply it out and actually do it the long way, it'll turn into this. But factoring and multiplying out are opposites of each other. So the idea is now if I start with something like this, I can know how it factors. So for example, if I say factor x squared minus 8x plus 16, I can now use this shortcut by realizing that this looks like x squared plus 2 times negative 4x plus negative 4 squared. So that means it factors into x minus 4 times x minus 4, aka x minus 4 squared. So it's a bit of a shortcut, but it's sort of, I don't know, it's sort of like too much to memorize. It's easier just to do the process if you don't know how to factor this than to try to force it into the shortcut working. But in any case, it is a shortcut if you happen to remember it. Let me do one more. So if I do x squared, let's see, plus 12x plus 36. The identifying factor is looking at the last number and realizing that it's a square. So 6 squared is 36, and then realizing that 2 times 6 is 12. So this is going to be x plus 6 squared. That's the shortcut. But again, don't rely on the shortcut too much. If it's too much to remember, just do it the long way. Okay, so that's one more shortcut. I got one more to do, I think, or two more. These ones are just sort of memorization. So there's the difference of cubes. I'm just going to run through it real quick. X cubed minus a cubed. Instead of squares, we now have cubes. This one, we don't really know how a method for factoring cubes. We only have the box method for squares. So we can't really like show that this one works by actually doing a process. Instead, you sort of have to just trust me that this is the right answer. But you can actually check it by multiplying things out. So that's the good news. So this is the difference of cubes formula. So the way I could check it is I could actually multiply this out and add it all together and it makes sure that I do get x cubed minus a cubed. So in practice, I would use it on something like this. X cubed minus 8 is x cubed minus, well, 8 is actually a cube. It's 2 times 2 times 2. So now I can use the formula. X minus 2, x squared plus 2x plus 2 squared, which would just be 4. And again, I could use it for slightly more complicated things. So I could do something like 8x cubed minus 27. And instead of just x, as long as I write that first thing as a cube, so it's 2x cubed because 2 cubed is 8 and x cubed is x cubed. And then 27 is 3 cubed, 3 times 3 times 3. So now I can use my formula again, except instead of just x, it's 2x. So 2x minus 3, 2x squared plus 3x plus 3 cubed, sorry, 3 squared. So I guess I can slightly simplify it. 4x squared plus 3x plus 9. So we're not going to really use this one too much. It's just interesting that it works, and also that the sum of cubes works. Oops. So that's the last shortcut. Sum of cubes also factors nicely. X cubed plus a cubed instead of x cubed minus a cubed. And it's almost the same, except it's x plus a, and then x squared minus ax plus a squared. So in practice, it's more important just to know that these formulas actually exist than it is to memorize them, so that if you ever happen to see something of this form, you can go look it up real quick and remember what the formula is and use it. But let me just do one example. So like x cubed plus 64. Well, 64 is 4 cubed. 4 times 4 times 4 is 64. So I can use the formula x plus 4 times x squared minus 4x plus 16. Because 4 squared is 16. Okay, so that's it for this video. I will see you next time.